Hi, today's lesson is graphing radical functions. So to graph the function, first of all, let's talk about the domain and range. You cannot square root a negative. So the smallest x could be here is 0. So when we're talking about the domain, it means that x must be greater than or equal to 0. And from there, the range, we're going to get only positive numbers. So y is going to be greater than or equal to 0 as well. So is it increasing or decreasing? Well, as x increases, y increases, so it's increasing. But if you take a look at the graph, it looks something like this. It's kind of a swoop that way. So if we talk about a cubic instead of a root, the domain is actually all numbers, because you can have a negative, you can have positive, it could be anything. And because of that, the range is also all numbers. And this one is increasing because there is no negative on the front. When the odd, it starts low, ends high. This graph looks sort of something like this. It's kind of like an S curve, like that. So here's the general form of a radical function, where n can be even or odd or whatever. If it's even, then it's going to be a swoop looking thing. If it's odd, it's going to be an S curve. So basically, if n is even, you're going to have something like that. If n is odd, you're going to have something like that. Now, this point I'm marking right here is your HK. That's a starting point, if you will, or vertex is HK. I'm going to call it vertex from here on out. So that's what we're looking for. So to graph these things, all we do is find HK, and then we go from there. So for a vertex will be the opposite of positive 3, so negative 3 and 5. Since this is a square root, we know it goes like that. So we do the graph. So we go negative 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5, put a dot. And then basically, we just go swoop. And if you want a perfect graph, just use graphing software. That is my opinion. Go ahead and try this one. Try this one. Okay, so an easy way to identify transformations with these graphs is to actually rewrite it where it's only x underneath the radical. So this one, for example, we have the 9, square root of 9 is 3, and we're left with the x. Now we know this is a slope or a square root function that starts at the origin and kind of increases by 3. So it's kind of a steeper one. Same thing with this one. See, we have the 4 underneath. Well, we know 4 and 16 share the 4. So we can rewrite it as that. And then the square root of 4 is 2. X plus 4 plus 7 on the outside. And so now from here we can identify the starting point, which would be negative 4 and 7. So if we graph that, it'd be over here somewhere. Since it's a square root, it's going to be a swoop. Specifically over 1 up 2 units. Go ahead and try this one. So how do we write the equation from a graph? First, we got to identify the center point or the vertex point, which is right here at 0, 0. And we know this is a cubic shape. It's an S curve. So we know, or we can assume for the most part that it is. So we can use this formula, which is a, the cube root of x minus h plus k. And we know hk is 0, 0, because that's this point. We just got to figure out what a is. And that's where it gets a little tricky, but you can use the graph to help you out with that. So y equals the cube root of x, because h and k are gone, Now, if we go over 1 unit and we go up 1, 2, 3, that is your A. So it's just 3 in the front. The other way to do it is to pick a point and plug it in, and you'll see it's exactly the same thing.